Good afternoon, ladies and gentlemen, dear participants, dear audiences. Welcome to the third day of Turkish Society of HVAC and Sanitary Engineers. We call it as TTMD, 16th International HVAC&R Technology Symposium. The last session of today, and actually the last session of the symposium, is dedicated to a panel discussion under the title of Contribution of HVAC Systems to minimize greenhouse gas emissions in the whole life cycle of buildings. Let me introduce myself first. My name is Gülsu Ulukavak Harputlugil. I am currently working as a full professor at Çankaya University Architecture, and I participated as member of scientific committee and organizing committee of this symposium, and now the moderator of this panel session. Dear participants, before we begin our panel discussion, I'd like to take a moment to say a few words on the topic that will shape all the presentations that you have followed during the symposium: embodied energy and carbon emissions in HVAC system design. As we all know, reducing carbon emissions is a critical part of global efforts to combat climate change. HVAC systems, while vital for ensuring indoor comfort and air quality, play a significant role in the carbon footprint of buildings. Traditionally, our focus has been on improving the energy efficiency of these systems during their operational phase. However, there is an equally important factor we must consider: embodied energy and carbon emissions. Embodied energy refers to the total energy required to manufacture, transport, install, and eventually dispose of HVAC equipment, while embodied carbon encompasses the greenhouse gas emissions associated with these processes. Often, these hidden costs are overlooked in life cycle assessments. However, as buildings move towards carbon neutrality and net zero goals, the importance of addressing both embodied and operational carbon becomes clear. The Greenhouse Gas Protocol offers a framework that helps us understanding these emissions, dividing them into three scopes. Scope 1 covers direct emissions from sources like fuel combustion in HVAC systems. Scope 2 deals with indirect emissions from purchased energy. And Scope 3, which is critical in this discussion, includes embodied carbon from materials, manufacturing, and supply chains. Today, our goal is to explore how we, as designers and engineers, can integrate considerations of embodied energy into HVAC system design alongside operational efficiency to reduce the overall environmental impact of our buildings. Well, without further ado, I want to move on to the panel session now. The panel is planned to consist of two main sessions. The first session will be dedicated to the presentations by three distinguished speakers. The aim of this session is to address the issue with the international dimension. In this context, a one-hour session is planned in which a framework based on a general concept is drawn, definitions are made, and standards and regulations are evaluated. Without further delay, I would like to invite the panel speakers to the screen. Our first speaker is Professor Thomas Lützkendorf. Professor Lützkendorf was up to 2023 director of the Center of Real Estate at Karlsruhe Institute of Technology. He holds a PhD and habilitation in the area of implementing sustainable development principles within the construction sector. Within the scope of teaching and research activities, he was concerned with questions relating to the integration of sustainability issues into the decision-making processes along with the life cycle of buildings. Professor Lützkendorf is a founding member of IISBE and involved as today in standardization activities at European and international level. Besides, he runs a consultation office. In this panel, he's going to talk about the overall landscape of whole life cycle assessment for buildings. The screen is yours, Professor Lützkendorf.
So, yes, dear colleagues, here we are, and so I will try to do my very best to move these slides here. And you can see the slides already. Okay, so, but it's frozen. You know, it's never good to have a good check, and the main problem is if it doesn't work during the main presentation. So I will try again. Wait a minute, and sorry for this, I'm so sorry. So, yes, and now I think it looks better. So now we can start, I hope. So sorry for this, and now we can start like in the theater, you know, the first attempt and the second attempt, but now it runs, I hope. So, ladies and gentlemen, I'm so sorry not to be able to talk to you in your beautiful language, but please, dear colleagues, please allow me to say mehaba. So, this panel here is supported by different groups of actors. We are representing here together different groups in the background, like ISPE, the International Initiative for the Sustainable Built Environment, but also the large ongoing international activity running by International Energy Agency Annex 89. And in a certain way, we are also representing here ongoing European standardization activities, CENTIC 350 Working Group number 3, represented here, by the way, by Julia. So, my name is Thomas. I'm the first speaker in this panel. And my topic here is overall landscape of whole life carbon assessment for buildings. So I am dealing with the overall topic on building level. And yes, it's true, we have to talk about a landscape. It's a complicated landscape, by the way, because we have so many elements to integrate here, like the definitions, the data, the benchmarks, the tools, the standards, and so on. First of all, what is our background? What motivates us? We are all motivated to save, let us say, our climate as the foundation of our daily life. And now the question is how we can contribute and why. If you look to latest statistics, we are contributing as construction and real estate industry to close to 40% of all man-made greenhouse gas emissions. So do not trust other statistics, because in some cases they are limited to direct emissions. But here, and this was mentioned already by Gülsu, we have to take into account scope 1, scope 2, scope 3. You can also call it direct, indirect, and embodied emissions. And if we take this into account all together, our contribution is more than 37%. In a certain way, we can say, oh, we are responsible, but this sounds a little bit tricky. From my point of view, we can say we can make an impact. We can make impact to reduce such 40% by our own activities. And this is our motivation today. And there is another thing which combines our activities here. You know, there is ongoing buildings breakthrough initiative around the world. And if you can see, the overall goal here is to organize a push for near zero emission greenhouse gas emission buildings up to 2030. And there is an interesting news. Also, your country, Turkey, is participating, like our countries too, like Germany or the northern countries represented here by Freja. We are working all together here, especially also in standardization, certification, and things like this. But also there is another B4 activity talking about latest developments in the development of technical solution, where also heating, ventilation, air conditioning systems coming in. There's a job sharing among us during these presentations. Freja will talk about the building component level as a heating, building, ventilation, air conditioning system. Julia will talk with point of view from construction products. But my object of assessment at the moment are the buildings. So at the moment we are on the building level, and our panel here is like an elevator coming down from building level through component level down to product level. So we are able to cover all such levels in our panel here. So first of all, whole life carbon. It sounds good, but you know, there are so different ideas around the world. as well as so many different terms and definitions. And some people are a little bit nervous already. So here is a list of terms you can use. And the terms in red, this is my personal recommendation. Because if we take whole life carbon is fine, like in our conference here. But if you talk about whole life greenhouse gas emission, you know already the measurement unit, the greenhouse gas emissions. Some people mix up the carbon and the greenhouse gas emission. So we are talking here about the greenhouse gas emissions. For sure, you can call it global warming potential, or you can also call it carbon footprint or carbon performance. But in my point of view, it's my recommendation to use whole life cycle greenhouse gas emission, which is also used in Europe in several documents. And for sure, there is an ambition level to select. And perhaps you have heard about this, and I'm sure sometimes we will see a smile in your face if you see a debate about nearly zero or nearly zero or whatever, and how far is nearly zero to zero. So it's not so easy to answer. You can see again a longer list, low carbon, nearly zero, and things like this. From my point of view, again, a very clear recommendation, talk about net zero. Net zero will already provide you with a signal behind there is a balance. And so you can see at first we have the measurement unit, the greenhouse gas emissions, and now it becomes clear we need a balance to calculate the greenhouse gas emissions and perhaps to compensate under very specific conditions. So the question is, what is the meaning of net zero? For sure, there are again different perspectives, but my recommendation is to talk about economic compensation or technical reduction. But the first, there is a precondition to reduce as much as possible. And later on, you can think in a second step about reduction or compensation. Our final goal for sure is an absolute zero, but it's hard to achieve. So therefore, we need an agreement how we will organize economic compensation or technical reduction. I invite you to take into account several sources of standardization. You know, around the world, there are different organizations like HVAC and others, but here I'm involved, for instance, in ongoing standardization activities at international level organized by ISO. And you can also use this in your home country because it's international standard. There are some rules for environmental performance assessment. If you are interested in terms and definitions and recommendations, how to create indicators, how to define benchmarks. And for the existing buildings, there's also a carbon metric for existing buildings in use stage. This is perhaps very interesting for facility managers. And I'm sure among our participants here, perhaps there are also in addition some facility managers, so you can have a closer look to this. This is what we are discussing at the moment here in Europe. There is the ongoing European standardization activities 15978. If you go to literature, you will find the old one from the year 2011. But at the moment, we are working hard for a new one. This creates the basis for whole life carbon assessment, calculating the greenhouse gas emissions. You can see we have a building model and especially a model of the life cycle, And we will subdivide here the life cycle into specific stages, product stage, construction process stage. And we subdivide the stages into modules. And so we can have a very precise idea what's in, what's out. All such things are defined by specific modules also to allow transparency. So if you go deeper into this topic, it's my recommendation to take a picture like this to understand in a much more better way system boundaries and what is included in your calculation and assessment. Therefore, perhaps it's important to understand the two very important parts. We have the so-called gray part, and this is a nickname for this embodied part, and we have the operational part. And again, you have different options to express this. as initial or recurring emissions or building-related greenhouse gas emissions, but there is a new language around the lifecycle impact assessment specialists, the name of the modules. And you can see left-hand side and right-hand side how you can express your system boundary by make reference to names of modules like A1 to A3, which is the meaning of creation of the background raw materials and pre-products and things like this along the supply chain. And later on, my colleagues will provide you with additional information in a more detailed level. But I like to just to show you for 1 second here, you can also use it for your object of assessment, the heating, ventilation, air conditioning systems. And you can have a very clear idea where you can make an impact on the embodied part and where you can make an impact on the operational part, because you are a very important sector. You can improve on both sides. Later on, my kind colleague Freja will tell you more about this. My responsibility here is to explain to you the landscape. And the landscape is dominated in Europe, by the way, by orders of European Commission. There is the Energy Performance of Building Directive, which was in the past concentrated on operational energy. The order was always, let's look for zero energy building. But this is no longer the headline. In our days, the headline is low or zero carbon emission buildings, no longer zero energy building. Because, you know, you can use energy, but it must be renewable energy. So it's more important to talk about the emissions. Left-hand side, you can see it's already a requirement to talk about global warming potential, which means greenhouse gas emissions, in the full life cycle. And here the important terms are mentioned: the embodied, the operational, and the indirect emissions. So we have the scope 1, scope 2, scope 3, like mentioned by Gülsu. You will see in 2025 already, European Commission will come out with a delegated act. This creates a frame how to calculate, how to assess the greenhouse gas emission in the full life cycle again. And the countries get invitation to develop roadmaps, also to develop something like benchmarks or limit or target values. And again, you can see here, there are already some requirements or system boundaries take into account. Reference study period of 50 years. Please do not mix it up with expected service life. Expected service life, this is real world. But reference study period, this is an artificial model. And we take the first 50 years of the full life cycle into account, because to think into future, for 100 years or more, we have increasing uncertainty. So there is agreement, let us take the first 50 years in the service life as reference study period. And you can see there is a must already. In 2030, each country should show already life cycle related global warming potential in future in the energy performance certificate. They have chosen energy performance certificate because this is the only official instrument at the moment able to provide a place for such information. I'm sure in future we will see this as partial information in digital building logbooks, also called building passports. There is another thing very important for people representing industry, real estate industry, financial industry, and so on. It's called taxonomy. There's another requirement for larger buildings. You have to show the result of global warming potential calculations through the full life cycle based on the standard to your financial institution if you ask for a loan. Therefore, it's very interesting to take this into account. Look to the small remark right-hand side. You know, for sure it's very specific for European market participant, but also for some countries around. Therefore, it should be also of your interest, dear colleagues from industry, to provide information. Perhaps you have client inside Europe, or other more international banks will also overtake taxonomy-related consideration and requirements. So I invite you to take this into account. And if you are not familiar with the Levels framework, Levels is a European sustainability reporting framework to show important sustainability-related information to clients and third parties. And one out of this is global warming potential in the full life cycle. Why I come back always to this full life cycle? Because in the past it was limited to operation, and there is still an ongoing debate we should include embodied or not, but therefore it's very clear full life cycle. What are the current trends? Thanks to all the engineers and the designers, we are able to reduce operational energy demand and operational greenhouse gas emission. But at the moment, we are paid in a certain way with increasing embodied carbon. And therefore, now we are motivated also to reduce this. There are good examples. Here's an example from Denmark to come out with a plan how to reduce overall greenhouse gas emissions in the full life cycle. And we have for the sector, in this case, construction and real estate sector in UK, such a mitigation pathway. So you can see how this looks like. I was able to identify such pathways for your home country, but there was a small problem that this gives reason to do more. And this is the reason why we meet together here. So you can see you need a more effective strategy, to reduce all the embodied carbon in future. And therefore we need your kind support from heating, ventilation, air conditioning industry. So at the very end, what means landscape? I call it package. At the very end, we need a package out of assessment method, data, the design and assessment tools, but also the benchmarks and target values. And this creates a package. Therefore, we need the data, and we will come back to this now. How we, the participants today, can help you. We all together working on Annex 72 in the past, and this is for free. This is available already. At the moment, we are working hard in Annex 89, and we will provide you additional information. And around us, there are so many organizations providing useful information. You can also see quantity surveyors. We are Royal Institution of Chartered Surveyors, providing calculation rules and things like this. From my point of view, already we have too much different materials and guidelines, so we have to select the appropriate one. What are my recommendations? I have to hurry up. First of all, to the policymakers, my recommendation is to develop a national reduction pathway, but also to introduce legal binding requirement to limit greenhouse gas emission in the life cycle of buildings. Legal binding requirements. For science, I invite my colleagues to work hard with us to further develop the calculation assessment rules, and we have to solve the problem how to take into account more dynamic consideration. And now for you, the participants from industry, please provide us as an average value for the industry, but also as a company with specific data for your products in case of environmental product declaration. We need really information like this. So thank you for your participation here. And we all together do this in the spirit of SDG, the SDG number 17, good and peaceful collaboration. This is the spirit we like to invite you to jump in here. And I like to invite my colleague Freja, the next speaker. So back to you, Gülsu. Thank you. Thank you to your colleagues. Gülsu, you are still muted.
I think now it's okay. Sorry for that. Thank you, Professor Lützkendorf. It was a very useful presentation and gave us a general perspective to the subject. And I'm sure that it helps us to concentrate the topic better. You clarified the topic from all perspectives, and I'm sure that there will be further questions, and we will discuss all these questions later on the second part of this panel. Now, our second speaker is Dr. Freja Rasmussen. Freja Rasmussen is an associate professor at Norwegian University of Science and Technology. Her research interests lie within environmental life cycle assessment of buildings, especially how methods and tools are used in practice for building design. She was involved in the development of life cycle-based regulations in the Danish building codes and has been part of several international projects dealing with life cycle assessments in the built environment. Among these, the EAI-EBC Annex 89, where she operates as a sub-task leader. In this panel, Dr. Rasmussen is going to talk about HVAC and life cycle assessment of buildings, Nordic experiences. The screen is yours, Dr. Rasmussen.
Thanks a lot, Gülsu, for the nice presentation. I will share my screen and presentation here. Okay. Yeah. Yeah. Okay. So very happy to have this invitation to participate in the panel debate. It's such an interesting topic you're dealing with here. I added a tiny plus to the HVAC in my title here, HVAC plus in life cycle assessment of buildings, the Nordic experiences, because going through the material I have from my dear colleagues around the Nordic countries, I also realized that we have quite different perspectives of how much to include when we're talking about technical service systems in buildings. So I will acknowledge the input I had for this presentation from colleagues from Aalborg University in Denmark, Uppsala University in Sweden, Aalto University in Finland, and Multiconsult in Norway. What I will take you through in the next 15 minutes is a bit of a introduction to the harmonization work that has been going on in relation to building LCA in the Nordic context, and specifically with a focus on HVAC+. And then I'll provide a few deep dives into some examples from these countries. So I also added a tiny plus to the Nordics because originally, Nordic collaboration has been going on for well, centuries really, but on a political level for several decades from before entering the EU. There was collaboration between the Nordic Council of Ministers, so that's actually several different councils working in different thematic fields. But they share this common vision in the Nordic Council of Ministers that the Nordic region will become the most sustainable and integrated region in the world by 2030. Big words. Initiatives needed to support this. First of all, I will highlight which Nordic countries we're talking about here, also in respect to this harmonization. So we have Iceland, Norway, Sweden, Finland, and then I had to downsize the dot not to cover Denmark fully. And then the plus when we talk Nordics here relates to the fact that we also have Estonia, the Estonian ministries involved in the harmonization work going on within the Nordics. So this is a collaboration that's going on, coordination activities between the different institutions in the Nordics. Several initiatives are happening within this coordination for Nordic sustainable construction. So one pillar of this is to talk about the way life cycle assessment is being applied to the built environment, trying to harmonize method. It has proven difficult, but at least there's coordination going. There are also focus areas of circularity, materials and architecture in general, emission-free construction sites, and competences for reuse. And in this collaboration activities, apart from the authorities, there's also representatives from the industry represented, as well as research and education. So it's a broad selection of stakeholders that are working together to improve the agenda here. In a way, you could say that the Nordic collaboration here is in line with recent trends on a global level also. So this is a chart taken from the OECD Global Survey on Buildings and Climate. So 28 countries representatives have reported what they see as current policy areas, the darker blue, and what they see as future policy development areas. And as you see, the energy-related policies are already to such a developed level that now the future focus is believed to be within embodied carbon and circularity of building materials. So this is what the countries are looking into and what this Nordic collaboration aims to do. Materials and carbon are thus in the spotlight for a lot of policy developments, not only in the Nordic region, but also globally. This is a chart where you can see the different targets that has been set up for the for the Nordic countries, and how this the climate declarations and the work with life cycle assessment in buildings fit into a larger framework, because it's a part of a bigger plan. So each of these countries, the Nordic countries that you'll see here on the left, they have targets, overall climate targets, and the introduction of greenhouse gas declarations into the building regulation has been a milestone towards, one of several milestones, of course, towards these overall climate neutrality objectives. So what you can see on the lighter blue squares mark how life cycle assessment greenhouse gas emission declaration has been introduced into the regulation in Norway and Sweden in 22, Denmark in 23, and thus planned for the other countries to come in 24 to 26. In the revised version of the Energy Performance in Building Directive, we'll have whole life carbon introduced as a requirement from 27 for specific buildings. What you'll also see here is that the Nordic countries are also working with limit values. So that means when obtaining a building permit, you need to comply with a maximum, there's a cap on how much greenhouse gas emissions can be associated with the building, to be constructed. And that was in place already in 23 in a Danish perspective, and has been prepared for Finland and Sweden for introduction from next year. So there's a lot of experience and learnings from this process that are coordinated between the countries for now. You'll also see from this chart with the different countries and the different life cycle stages that are included in the building regulations, how different the scopes turned out to be. To the far right, you see the scope that's introduced by the European reporting framework levels, supposed to include all life cycle stages, and then you'll see how the different Nordic countries, they include a selection of these life cycle stages. However, there is an ongoing discussion in these harmonization forum for the Nordic countries how to align best with the upcoming requirements in terms of levels. But you'll see from the darker blue, those are the ones that are already included now in the building regulation, and then the lighter blues are the developments that will be included in the regulation. So it's also a stepwise approach to make it more comprehensive, the building regulations. Now, getting to the HVAC plus. It is a part of the inventory scope for now. So when you make your climate declaration for a building, you do include it in some of these assessments. But as you'll see, for instance, in the Norwegian building regulation, it's not a part of the scope. So it's varying how to which degree we take into account these technical systems in the Nordic countries. And you'll see here how they are also differing on the different types of building services, whether electricity systems are taken in or fire fighting systems. So when we then include HVAC plus in the climate declarations, of course we need the data to do so. And one thing is about the inventory, what's our scope of inventory, and another thing is about the life cycle impact assessment data that we use to represent the HVAC systems in the buildings. And I know that Julia will talk a bit more into the details of the products, but I will show you here an example from the Finnish context where there have been established standard values that can be put into the climate declarations if it's not possible to get the detailed inventory from a building. Then these standard values can be used. What is worth highlighting here is actually the ventilation system, how much it accounts for these totals. You'll see from the A1 to A3, the ventilation system accounts for a lot of this, both in so it's 46 out of 105 for the production phase, A1 to A3, and 91 out of this, 91 ventilation system accounts for 91 kilo CO2 equivalents per square meter out of the 112 for these standard values in the replacement stage for these Finnish values. So about the inventory scope, this is an example from a Danish study where they looked into what's the difference between having the sort of the drawings and using what we have of knowledge on the building as such, and then using the BIM model. So what's in the building regulation and what's in a BIM model, how much you take out of the materials there and what it means to the results from a greenhouse gas emissions perspective. And you can see, so these are for 3 different schools. So it's only 3 examples, but you can see the difference when accounting for everything that's actually modeled in a BIM model, a technical BIM model. It accounts for plus 48% and up to 166% extra from the original. And it can be due to various reasons. For instance, this school number 3, where there certainly was a large impact from the plumbing drainage, was because of a large basin, a plastic basin, underground basin to store water in. So it's it does have an influence which inventory scope we have and how we get to that inventory scope, of course. Now I'd like to show you a few of the research examples that are happening throughout the Nordics now. This is a Swedish study with multi-optimization of a new construction where our colleague Farshid Shadram, he has looked into different parameter variations of these first M1 to M9 passive measures and then some active measures to improve the life cycle energy efficiency and embodied energy in this building, and with different reference study periods here from 50 to 150. The key point here from this Pareto front of the multi-optimization with the operational energy on the one side and embodied energy on the other side is that the best solutions, they have this geothermal heat pump and AC for cooling. So it's actually quite material intense, but then again, you save sufficiently amounts of operational energy in the operational phase. A Norwegian project I'd like to highlight here is from my colleagues at Multiconsult that are also looking into they have a research project going on what's behind the building facade. So this is another example of a school and the BIM model showing just how many installations there are actually involved in a complex building like this. So the whole research project that they're dealing with is to increase the level of competencies, knowledge, and services around this area, and in the end to show the way to 50% greenhouse gas reductions in some of these exemplary projects. So what they find is that the HVAC Plus is significant for high-performing buildings. It's also a costly affair to deal with, and there is a high amount of material. So it's in focus in the construction phase anyway, and we might as well include it in the greenhouse gas emissions calculations. But it's per now in the Norwegian system not part of the climate declaration. Sorry, too many animations going on here. Okay, this is the next one. So what they have looked into is also the difference between a reference building and an ambitious building. And you can see here in the figure how a reference building, the sanitary heating system, fire safety and ventilation make up an amount of approximately 20%. But if you work hard on reducing your greenhouse gas emissions from the materials, then it's still difficult to do something about the systems services, and they can end up making more than 30% of the total greenhouse gas emissions. So one of the conclusions from their project so far is also that there is an increased importance of technical systems, and we need to include it in the climate declarations. Finally, this is a kind contribution from my colleague, Professor Thomas Lützkendorf, is taking it outside of the Nordic context. We also have other examples. So this is an example of a US refurbishment example where you can see here on the top, we have the embodied carbon of building services compared to the whole building. So we're talking the complex systems, you can have up to 50% impact from the technical systems. But it can be as low as these 15-20% in a low impact scenario. What's also interesting here is to see what are the most contributing components here. So for the electrical, we have the lighting, the power, and for the plumbing, it's the drainage system that's taking up a big chunk of this. For the HVAC, we have the ventilation system, and then there's also the refrigerant leaking. That's definitely something to be aware of, and is not always included in the scope either, the climate declarations. So enough of things to worry about and to tackle, and of course we will just get on with that. To sum up, there's an increased significance of HVAC plus in these climate declarations that we're dealing with in the Nordic countries. We acknowledge the use of BIM. It provides detailed material amounts, but it's also a political discussion of how much we want to include in these climate declarations in the building regulations. And then we have some standard values for HVAC plus established in the Nordic countries, but they vary quite a lot in their scope and what they include. So this varying of scope is also something to be aware of when working across different methods. It always comes in a package, as Professor Lützkendorf said, with the method and the tool. So with this, I would like to say thank you. And over to you, Gülsu.
Okay. Thank you for this impressive speech, Freja. And I'm sure that Nordic countries, this ambition and LCA perspective will give valuable inspirations for the other countries and regions. Anyhow, now I kindly invite our third speaker, Mrs. Julia Gorke. Mrs. Gorke is consulting director and head of buildings and construction team at Spera Solutions Sustainability Consulting Organization. Julia Gorke has been working in the environmental field for over 30 years and has over 25 years of LCA experience. At Spera, her work focuses on LCA, EPD environmental product declaration, and EPD automation projects for national and international companies and associations in the building sector. Julia Gorke is a member of the German Mirror Committee of the EPD standard and 15804, and since February 2020, convener of European CEN standardization, Working Group 3, Sustainability of Construction Works product level. She's a chemical engineer with a degree from Aachen University of Applied Sciences, Zurich campus. Today, she's going to talk about requirements and use of environmental product declarations, EPDs, for HVAC systems. The screen is yours, Mrs. Korke.
Thank you very much, Gülsu, for this kind introduction. Can you hear me? Can you see my screen? So, fine. So then I will start. And thank you very much for the invitation. I have the pleasure to introduce the topic environmental product declarations to you today. And I would like to start with the questions that I hear every day. So when someone reaches out to me or my team, and we developed hundreds of EPDs in the last years, single EPDs, but also EPD tools, the question are very often, so what is an EPD? How do I get an EPD? What is a PCR? What is an LCA? And maybe you are also curious to understand if an EPD is also relevant for the HVAC. So let's see. I hope in the next 10 to 15 minutes I manage to bring some details into this topic. So first of all, I would like to introduce what an EPD is. So an EPD is an environmental product declaration. It's a document, so 8 to 10 pages, and it contains the results of a life cycle assessment. So for instance, the information on the global warming potential or the acidification potential or the primary energy use. It considers the product from cradle to grave. And after the presentation from Thomas and from Freja, I think you are all very familiar with the different modules, A1, A2. So I think this was already a great introduction. EPDs are independently verified, so they have a high credibility, and they are so-called type 3 labels according to the ISO 14025 standard. The EPDs are based on either international standards or EN 15804 plus A2, and here this EN 15804 standard group, I lead this group. I'm the leader, I'm the convener. Additionally, I would like to introduce the term product category rules, because it's important that the LCA requirements and the methodology is harmonized for the different product categories, and there are different requirements whether an EPD is developed for carpet or for 1 ton of concrete, or if it's developed for a piece of HVAC. And I come to this later. So just to give you a little bit an overview of the different acronyms and the terms that I'm going to use in my presentation. Okay, let's have a deeper dive into the content of an EPD. As I mentioned before, it's third-party verified. So an EPD always contains one page where you have the signature of the verifier and the program operator. Then you find the product and production information in an EPD. And there is also a part where you find the parties involved. So the program operator, this is the body that publish the EPD. We have, so in this case, for instance, Sphera, so the company I work for is the LCA practitioner, and you have the owner of the EPD. And then you have the different life cycle stages and the environmental impact of the different life cycle stages. And as you already learned, it's divided into the product stage, into the installation stage, the use stage, and the end of life stage, and then the recycling potential, so the benefits and loads beyond the system boundaries. So the modules are very important, and an EPD is then meant to be used on building level so that the architect or planner can collect the EPD from the floor covering, from the concrete, steel, the windows, the doors, in order to calculate the life cycle assessment of a whole building. Okay, so this is the content of an EPD. And now maybe you're curious where to find EPDs. I found one for an HVAC product at one of the program operators. So it's always a third-party verified document. And the International EPD system, for instance, is one of the EPD program. So the Swedish EPD program has published one EPD for an HVAC system. You find the links in this slide. If you want to have a look at the specific EPD. And if you wonder where to find all these EPDs, I would say a good entry point is the ECO platform. ECO platform is the European organization where all the different EPD program operators work together and harmonize the different requirements from the national EPD programs. So ECO platform, you also find the link here. And just to give you an idea on how this looks like, at ECO platform, you find a database where you can search the different EPDs that are published so far. Okay, good. My next slide just introduce the term product category rules. This is very important. This is also important in the standardization work that I do. As mentioned before, the LCA requirements, so the requirements to calculate the carbon footprint or the global warming potential for a carpet is different to the requirements for an HVAC. Yeah, well, this is clear. You know, the floor covering is declared per square meter. For HVAC, you have different functional units. For concrete, you have different requirements. So it's very important that the different industry write so-called product category rules. Yeah, a product category rule is meant to ensure that the EPD is that the EPDs are comparable and that they are all on a, let's say, level playing field. Yeah, just to mention this because this is also one part of my standardization work where we review the different PCRs in order to ensure that on building level the requirements are all harmonized for the different product groups. Okay, so on the next slide, I would like to introduce the use of EPDs. EPDs are used in for legal regulations. I come to this, especially the developments in Europe on my next slide, but overall, there are now some legal requirements to develop EPDs and to use EPDs. You can also use the EPD for eco-design due to this modularity at the end of an EPD project. Every construction product manufacturer has a good understanding of the environmental impact of the manufacturing stage, of the installation stage, of the use stage, and of the end of life. So this is always, I would say, the fun in an EPD project, not only to hand over a nice document, but also to have a better understanding where the hotspots and which materials are the main contributors. Marketing is also relevant. You know, it's important to communicate the information in an understandable way. Acidification potential, eutrophication potential, all sounds a little bit more scientific, but it's very often important to also include marketing to translate this into a language that can be understood by everyone. EPD requests from suppliers in both directions. So it might be that you as a HVAC manufacturer are requested by the building level, for instance, please can you hand over the carbon footprint information in an EPD, but it might also be that you request from your supplier the relevant data in an EPD format so that this all matches together in the correct way. Green public procurement. Here we have some European requirements for GPP and EPDs are also mentioned. And as we learned from Thomas and Freja, this also enables building LCA. Okay, legal regulations. Legal regulations. The CE mark in Europe is confirming, on the one hand, I would just like to explain what CE means. So CE is the European conformity, and all the construction product need to follow certain requirements, and they need to have the CE mark. So the example that I show now on the screen is from a floor covering. Floor coverings can be used in buildings in Europe when they follow, and when they are labeled with a CE mark. And for floor coverings, for instance, there are requirements on the burning behavior, there are requirements on the slip resistance, there are requirements on the indoor air emissions, so formaldehyde emissions here, for instance, and there are also requirements on the electrostatic behavior. Yeah, so without a CE mark, it's not possible to use construction products in Europe. Okay, and this is all regulated in the construction product regulation. In the past, and this is the CE mark that I presented in the slide before, it's about structural integrity, it's about fire safety, it's about consumer protection and worker protection. And now the environment enters into the picture. So we have now the requirement 7 and we have the new requirement 8, which says hazardous emissions into the outdoor environment of construction works. And here also the CO2, so the greenhouse gas emissions are meant, together with sustainable use of natural resources of construction works. And both 7 and 8 is part of an EPD. So what we are now facing is that we have a new construction product regulation. It was revised and is now approved by the European Parliament, or was approved in April. So soon will become, will get into force. Long story put short means that the CE mark needs to contain EPD information in the future. So the LCA in the CE marking requires that in the declaration of performance and conformity, LCA information and EPD information need to be listed, all in a digital format. First, they will focus on the global warming potential, but next to come, so all the other indicators in an EPD will also be part of this exercise. The underlying standard is the EN 15804 plus N2. You will have a notified body confirming what is declared in the declaration of performance, and you need a verified LCA. Okay. So this is what we are expecting. Besides, let's say, the consumer protection aspects, also the life cycle assessment and EPD information will be part of the CE mark. If you wonder, how do I get an EPD? I just would like to give a short overview on the different steps in an EPD project. So first of all, you need to decide which product you need an EPD for. So define the product. You need to cross-check if there are product category rules available. So the one from the carpet is not usable for an HVAC, for instance. Then the HVAC manufacturer need to collect data. So you need to collect the raw materials you are using, the energy that you are using, and you need to collaborate with an LCA practitioner, and this person will calculate the LCA results. Then the reporting is essential. So background report, it's like a test report, as well as the EPD document needs to be developed. And last but not least, we have the verification and publication before you can publish your EPD. You need the independent third party that verifies your document. So with this, I hope that, and I let's say self-confident, put all the speech bubbles green. So I hope that I could give you a short overview of what an EPD is, what you need for an EPD, what PCRs are, what an LCA is. And I would say, also following the presentation we heard from Freja and from Thomas, EPDs are relevant for HVAC. Thank you for your attention, and I'm looking forward for your questions, which we will answer after the next presentations. And with this, I hand over to Gülsu again.
Thank you so much for this valuable information. that you shared with us. I'm sure that many of these questions are now clear in our minds. And as far as I understood from that, for the HVAC systems, EPDs are valuable tools to assess and select equipment based on their environmental performance throughout their life cycle. And EPDs allow a more comprehensive understanding of HVAC systems' environmental impact, guiding choices that align with broader sustainability goals and regulatory frameworks. And I'm sure that we will discuss later on in this second part of our panel. Thanks again. And now I'm sure our audiences have many questions and comments in their mind. Please send us your questions from the send question part at the bottom of your screen. The question and answer session will be held after all presentations are completed. Meanwhile, we now jump to the second section of the panel. In this session, a roundtable discussion is planned, actually. Together with the previous speakers, there are two more invited speakers from Turkey. And before discussion, I'm going to invite other two speakers respectively. Immediately afterwards, a roundtable discussion will begin in which all the speakers will participate, and it will be further enriched with questions from the audiences. Now it's time to invite Mr. Samet Yılancı. Samet Yılancı completed his electrical and electronics engineering education at Kayaçetin Technical University. Since 2014, he has been working as an environmental and urbanism expert in the Ministry of Environment, Urbanization and Climate Change. His work involves developing the methodology and software for the WLC-R application, which is an energy performance certificate application for buildings, as well as contributing to the development of the methodology and software for the YEStr application, a green certificate application in buildings and settlements. In addition, he has participated in numerous international projects, such as energy efficiency in buildings with GIZ, zero carbon buildings with VRI, where our ministry has a stakeholder focused on energy efficiency in buildings. In this session, Mr. Yılancı is going to talk about targets for building systems on the path to net zero carbon 2053. The screen is yours, Mr. Yılancı.
Hello. Do you hear me? Okay, I will share my screen. Okay. Yes, do you see my screen? Okay. Thank you for this kind introduction. And I'm joining this meeting on the behalf of Energy Efficiency and Installation Department under the Ministry of Environment and Urbanization and Climate Change. Today, I want to explain our targets for our building sector in the path to net zero carbon 2053. Especially, I want to give you some brief information what we have done in the previous years in the building sector in terms of energy efficiency. And I want to mention what we are doing right now and what we are planning to do in the coming years. And I want to give you some key facts on building sector. All we know that the building sector accounts for approximately 30% of global energy consumption and global gas emissions due to their operational purposes such as heating, cooling, lighting, and ventilation. And we know that we have a target in the Paris Agreement that we have to keep global warming below 2 centigrade degree. And for that reason, we have to take more steps to reduce these gas emissions to achieve these targets. And also buildings are one of the most vulnerable sectors experiencing the greatest impact from climate change, like extreme weather events or earthquakes. And all we know that we are witnessing the floods, typhoons all over the world. And also, you know that Turkey, a massive earthquake happened in the Turkey in the last years, and almost 15 million people affected from these earthquake, and almost 25% of like 2 million building stock was affected from this earthquake. So it's very essential to take measures for buildings. And also the buildings are one of the most important areas in climate change related policies due to their long lifespan, like 50 years, and high energy consumption, and the construction sector's significant role in the economy for growing economies like Turkey. And also, I want to give you some brief information of our building stock in Turkey. And we have almost 8 million building stock as of 2023. And when we look at energy balance tables, we can see that the residential sector holds the second largest share with 31% of following the industrial sector. And our building stock is gradually expanding year by year due to the new construction rates higher than the demolition rates. You know that we have a urban transformation target, and every year we are trying to transform our building stock. And this one is the first graph, is the distribution of our building stock by years. As you see that the 76% of our building stock built before 2000, and it means that before 2000 we don't have any mandatory regulation in terms of energy efficiency in buildings. So we have a big potential in these building stock, especially in these existing buildings. And in our assumptions, in the second graph, you can see that our building stock total construction area now it could be 4,000 million square meter as of today, but it will be around 6,000 million square meter in the 2053, and it means that almost 50% increase in the coming years, in the coming 30 years. And in the building code development, as I mentioned before 2000, we don't have any mandatory regulation in the energy efficiency in buildings, and we have TS 825 thermal insulation standard. In 1983, and then we revised it in 98, but these weren't mandatory or obligatory regulations. So we assume that before 2000 these building stock are not energy efficient, and after 2000 the first mandatory regulation, the thermal insulation regulation, was published by our ministry. And then when we come to 2007, the first law we call energy efficiency law, and this law was all the regulations today related with energy efficiency based on this law, energy efficiency law, in agriculture, building, industrial, whatever. If it's related with the energy efficiency, it has to be based on this law. And based on this law, energy efficiency law, we published energy performance of building regulation, and it covers not just the insulation of buildings, it covers architectural design, the technical design of mechanical systems or renewable energy of all the components of buildings it covers. And then with these regulation, the energy performance certificate was started. And after 2011, every new building has to get energy performance certificate, and it has to be at least C class, and the existing building has to get EPC2, but we don't have any minimum threshold requirement for existing building. And 2023, we released a new version of energy performance for building regulation, and we introduced NSEB concept. And in Turkey, if the building has 2,000 square meter, more than 2,000 square meter construction area, it has to be constructed with NSEB limits, and this NSEB limits says this building has to be at least B class, and they should use their primary energy demand at least 10% from renewable energy sources. And also the other one is TS825. This one is building thermal insulation standards. And in this standard, we divide Turkey into 4 different regions. The first one, hot humid zone. The second one, hot dry zone. And the third one is moderate dry zone. And the fourth one is cold zone. As you see, each region has different thermal conductivity coefficient for walls, roofs, floor, and window. And we are working on the revising these standards. I think in the next year we will publish the new one. And another one, the regulation of green certificate. The first version of these regulation we published is 2017, but the latest one we published in 2022. This regulation is not mandatory, but in the next year it will be mandatory for all public buildings, and it evaluates the buildings, not just energy efficiency. It evaluates the buildings for their usage of energy, the water, the waste management, the building material, and the life cycle assessment. Also, we have another part of this certification system that for settlements. And these settlements, we have 5 more chapters: the regional priority and settlement profile, sustainable land use, ecology and disaster management, transportation and mobility, settlement, neighbor or urban planning, and also social and economic sustainability. And last year, we published Turkey's building sector decarbonization roadmap, and this roadmap project carried out by World Resource Institute and with our ministry. And in this roadmap, we divided into 6 main sections: building, construction and demolition, building materials, existing and new buildings, renewable energy, climate resilience and adaptation to climate change, and also the last part of financing. And in this project, we try to figure out what can we do in the short term, medium term, or long term strategies for our building sector. And in this roadmap, we try to consider all the part of the buildings component, like production, construction, the operation part, and the end of part. So we call it operate, not just in this roadmap, not just we mention operational carbon, but we try to do something on the embodied carbon, and we try to make some actions on embodied carbon too. And in this roadmap, if we will go in this direction, is business as usual emission direction, our emissions will be 200 million CO2 equivalent in the 2053. But if we implement our actions, our scenarios, which we mentioned in our roadmap, we can save almost 100 million ton CO2 emissions in the building sector. And so we have a big potential in our building sector, as I mentioned in the beginning, especially in the existing building. And what I want to mention are other action plans. The first one is development plan. This development plan goal is to create sustainable and safe built environment that uses renewable resources. And in this development plan, we have some actions on construction materials, on the smart building designs, and also improvement of nearly zero energy building requirements, and also awareness raising regarding NSEB applications, and also the dissemination of the national green certification chain. And another one is second national energy efficiency action plan, which was the first one is published in 2017, and this is the second one. And we have 11 action in this action plan. And the action plan related with existing buildings or new buildings. As I said, we have in this action plan like almost cover all the component of building sector. And the last one is for climate change action plan, and it was between 2024 and 2028. And in this action plan, we have actions on improvement of energy efficiency in existing buildings and establishment of incentives and support measures regarding energy efficiency of improving buildings. And we want to develop our regulation in regards to making all new buildings compliant with NSEB. We know that we have an NSEB limit, the NSEB limits for the buildings that have 2,000 square meter construction area. So we want to disseminate of BIM tools for all the building. Also, we want to get all public buildings to get YEStr green certification. That's all. Thank you.
Okay, thank you for your presentation, Mr. Yılancı. Actually, it's also very important for this panel that to understand Turkey's current position and future perspective on net zero carbon declarations. So now it's time to invite the last but not the least speaker, Dr. Nuri Cihan Kayaçetin. Dr. Kayaçetin is an architect with an academic specialization on life cycle sustainability. Having worked as a professional architect for more than 10 years, he progressed in the field of academia with his master's and PhD studies at METÜ. He contributed to international energy efficiency projects as national expert and coordinator with the Ministry of Environment and Urbanization. In 2020, he joined KU Leuven in Ghent for his postdoctoral studies on socio-ecological construction. The study was based on a living lab approach where several circular and bio-based materials and methods were tested in a real-life setting. In the end of the study, a demountable housing prototype that is composed of hybrid bio-based wall panels was achieved. He's currently an assistant professor in Bilkent University, and his current research areas are integrated sustainable design, energy efficiency, circular and bio-based construction, and socio-ecological life cycle assessment of the built environment. Dr. Kayaçetin is going to present about environmental impact assessment of HVAC systems for zero carbon buildings. The screen is yours, Dr. Kayaçetin.
Thank you very much, Gülsu, for the introduction. So let me please share my presentation.
Ne söylemek istediğini söyler misin?
All right. So can you see the presentation in full screen, I guess? All right. So I think I should be one of the luckiest presenters to receive such a great introduction from the previous experts. And you will see many of the keywords in my presentation, and you can already consider it as an application of these concepts in the context of Turkey. So I would briefly tell you about our case study on environmental impact assessment of HVAC systems for nearly zero carbon buildings. So the aim is actually to show you how HVAC systems have an impact on embodied carbon of buildings and to distinguish the solutions to minimize the, let's say, whole life cycle carbon emissions to designing HVAC for these nearly zero energy buildings. All right, so I think I will keep short of the introduction and go over to the state of art on whole life carbon assessment on technical systems, and then I will present you my method for, or my method that we applied on NSEB buildings, office buildings in Turkey. Then we will consider these buildings as a carbon investment, and we will see how these buildings pay back these carbon investments in the end. So we discuss about 50 years of lifetime. So what is the shortest period that our investments return to us? All right, so you already see these images. Luckily, Thomas has already covered the reference, but I would like to point out the fact that embodied carbon emissions occur in a relatively short period when compared to operational carbon. So as you can see in the figure on the right-hand side, the yellow bars happens almost immediately. And then, let's say, between intervals of 10 to 15 years, we tend to repair our buildings, so embodied carbon increases with certain spikes. And then, of course, technical systems are included in this embodied carbon and also have influence on operational carbon, but their impact will increase in time because we invest in our building facades, so they will become more low carbon, but then the other components will have a higher importance, and this was already been highlighted by our panel. So some basics, again, not to go into too detail. In our NSEB definition, the embodied carbon is not a compulsory performance indicator. And this is also valid for many countries in the world, but these indicators are upcoming in the future years, so we have to get ready for that. And then to achieve NSEB, let's say to achieve zero carbon buildings, not nearly, we need better technical systems and renewable energies, that is for sure. And of course, assessment of current situation will be a method to achieve these better technical systems. So I just want to show you from an academic perspective the ongoing research, and you will already see that from top to bottom, the keywords of whole life carbon and actually technical systems are increasing. So the focus is, of course, on whole life carbon and embedded carbon, but for HVACs, heat pumps, and all air systems. And there is increasingly more studies being published. So we are at a good trend here. So then now we need to see how we can apply this information in the context of a developing country, Turkey. So my study will depend on the international standards, as mentioned, EN 15978 and the whole life carbon guideline from WICS. And of course, the study includes embodied and operational carbon of NSEBs with a focus on the mechanical installations. But to keep it simple, because there are many components in a building and we need to see the impact of mechanical systems, we only included building components that have an impact on thermal performance. So you will only see building envelope and inclusion of mechanical systems in the embodied carbon assessment. And then we only include primary energy demand for heating and cooling. As you can see, the impact of lighting or appliances are not included. All right, so we have a generic representative office. So we previously conducted a study with the ministry to define the average building for different typologies. So our study depends on this description. So it's not an actual building, but it's a representative office building that you might see in any city in Turkey. We compared two regulations, which was already explained by Samet Bey. So the baseline TS825 and the new NSEB definition. And we located this building in 4 climate zones. And then we performed a carbon payback calculation. So as I mentioned, we consider NSEB as a carbon investment. So we invest carbon in our building to decrease the future carbon emissions. And then we need to see if our investment really worth it. So as you can see in the formula, the top part of the formula is the embodied carbon, and the bottom part is the operational carbon calculation. So when we divide the two, we need to find out the year when our investment was actually paid back to us by means of mitigation of carbon. So our definition of the case study is a 5-story office building with over 2,000 square meters and a relatively average window to facade ratio, but it's higher than residential buildings for sure. And you can see at the table in the downside the differences between two regulations in Turkey. One is the previous TS825 and the other one is the new NSEB. So there are some critical differences. If you see the U values for windows, you will see it clearly. So the ambitions are high, but we need to apply and monitor these applications. All right, so of course, depending on these U values, we add more material to the building. So we have thicker windows, thicker insulation. So there are with an additional mass of material. So this is additional carbon, additional embodied carbon. You can see it in the kilograms given in the different components of these buildings. If I can show you with the pointer. So let's see on a zone 1, we have insulation in the external facade almost increased by 30%. So you can already imagine that there's already 20% of increased embodied carbon. And of course, you can check for the other numerical numbers, but in general, the embodied carbon is increasing, and that's for sure. In our study, we try to depend on local EPDs, like Julia has already explained. But of course, there's always a lack of data in life cycle assessment. In the current situation in Turkey, I couldn't find any local EPDs for mechanical installation, so I depend on international values. But the EPDs for the building facade are local. So we designed this study as an addition to the existing WLC-TR system. So as you can see in the center of this image, this is the WLC-TR system, and we propose an embodied assessment which can be integrated to the national EPC software. And for this study, we used fixed conversion factors for carbon, but it is possible to do this with a dynamic system, but for simplicity, we keep it with fixed numbers. Then what we actually have in the results is let's say, a two-sided graph in which in the right-hand side, we see the embodied carbon emission for NSEB buildings in 4 zones. So this is an immediate impact of additions. On the left-hand side, this is the mitigation through increased envelope performance of the building and also high performance mechanical systems. The trick here is that these mitigations are based on per year, but this is actually a total score. So we need to see when these mitigations add up year by year and pass the overall carbon emission that we conducted by designing an NSEB building. So in our study, you can already calculate from here, let's say for the 4th zone, we can already pay back this carbon almost in 4 years. So this is actually amazing, but keep in mind that our life cycle assessment study was limited. So as Freya mentioned, if we would have included all materials, the payback period will be longer. But for this study, for the scope, we find payback periods from 4 years to 10 years. And I will briefly go over the results and finalize my presentation. So the payback of NSEB with a better mechanical installation, as I mentioned, from 3 years to 11 years. And I should mention for our international participants that our carbon intensity is actually higher than EU. So that's actually sometimes act better when we talk about payback periods, because there's a higher potential for mitigation, so that when we use it, we can pay back our investment better. So this is actually an opportunity for our country. There are some percentages that I found, but I need to validate that. So HVAC systems generally tend to be at a ratio of 10% to 16%, but this would vary quite significantly if we extend the scope of the study. So we should keep in mind that we have to replace our systems in 15 or 20 years, and they also need to pay back in the future. But I hope this will be more easy in, let's say, 20 years. And then, of course, there are innovative research mainly in America and EU, and this one you see in the right-hand side is a project from Belgium, from an Interreg project. So as you can see, this blue box here is a mechanical room that is actually squeezed into a box. So this kind of innovative solutions may decrease the embodied carbon of mechanical systems, and it also eases the control of the system. And by conducting these new approaches, we can actually have even better systems in the future. So this is why my hope for next 10 to 20 years is better than what I showed in my results for the current applications. Not to keep it even longer, and the conclusions is, I think an LCA-based method is already upcoming for HVAC systems, let alone the building envelope, and the ratio of embodied carbon of HVAC will increase by the improvement of each regulation. So we really need to increase the number of case studies, because in Turkey, besides the lack of EPDs, the environmental product declarations, we also have a lack of data on actual building studies. So this is what we are doing at the moment. We will focus on real buildings after this study. So I hope I can give you some insights on actual applications. So thank you very much for all the panel, and I think we are open for questions. Thank you, Gülsu.
Yes, thank you, Cihan. Your vision gives us an inside information from the researcher's perspective in Turkey. I also would like to mention that together with Dr. Kayaçetin or Cihan and one of our other colleagues from Konya and I are involved as official participants in the EAA-EBC Annex 89 based to implement net zero whole life carbon buildings project in order to bring Turkish perspective into the EBC community level and also comprehend the other countries and regions approach. Now it's time to start the discussion considering all valuable presentations on the topic of embodied energy and carbon emissions in HVAC systems. In this roundtable discussion, I kindly invite you to discuss the expected directions of building sector, but specifically the HVAC sector on the way to maintain 2030-2050 targets of net zero carbon in the context of next steps and recommendations to act. But parallel to that, actually we have questions to enrich our discussion, and I just want to read two of them to you. The first one is, how do you think the EPBD contributes to the EU's broader climate goals, such as achieving climate neutrality by 2050? Are the timelines and targets within the directive sufficient, or do you foresee the need for further tightening of standards in the near future? And the second one is, again, very parallel to that. The EPBD focuses heavily on operational energy efficiency. How does it addresses the embodied carbon in building materials? And do you see any further amendments that might integrate this aspect more robustly into the directive? So the questions and the subject is here, and I just want to ask you to start to give comments on these subjects and questions. Who would like to start first? Yes, Thomas, please.
So let me be the icebreaker, dear colleagues, and later on I invite all my colleagues to jump in. So I will start with question number 2.
Okay.
Question number 2 is a little bit a storytelling, you know. If you look to the Energy Performance Building Directive in the past, for sure it was all about operational energy. But the final target was always already to save energy, but also to save emissions to global environment. This was from the very beginning, but not expressed well. Later on, there was the idea, oh, let us talk about zero energy. But in the latest version, really new from this year, let us say, in the latest version, there is a double strategy. From one hand side, Energy Performance Building Directive is no longer asking for zero energy building, but for near zero emission building. And they talk about, first of all, about near zero emission building in operation. So if you look to the terminology there, you will see zero carbon or zero greenhouse gas emission in operation. But there is another stream inside Energy Performance Building Directive now called Life Cycle Global Warming Potential. So it's in parallel. From one hand side, they still like to reduce operational energy, and they like to see near zero greenhouse gas emission in operation. And this should also become expressed in the energy performance certificate. But there is a parallel stream now asking already for life cycle related global warming potential. And as mentioned in my presentation, at the moment, European Commission is working to develop delegated act. Delegated act will come in 2025. And so European Commission will come out with a framework how to calculate global warming potential in the full life cycle of buildings, including embodied carbon. So it's there already, and the figure should be included in the energy performance certificate as additional information. So it's there already, but it's a small problem. There are developments in parallel. Left-hand side, EN 5978, the standard. Right-hand side, delegated act. But in the background, and this is advantage, we all are colleagues. So therefore, there is an informal collaboration between all of us. And so we will see a job sharing. Delegated act will create a framework, and EN 5978 will provide us with the details of calculation and assessment rules. This is what I can say for the moment. But there is a small target conflict. Energy Performance Buildings Directive will ask us very soon to calculate the global warming potential in the full life cycle. But construction product regulation gives time to industry to provide us with data. And now you are able to see this target conflict. We shall calculate without data. This is not a good idea. And therefore, we must invite our colleagues from industry, please speed up. Do not wait for, let us say, your time you have to deliver. Please help us today, because we are under high pressure to calculate today. We need your data, your colleagues. Please wait not for legal requirements. Thank you.
Thank you, Thomas. And Freya, yes, please.
Thank you. I couldn't find any virtual hand, so I used a real hand to show my interest.
Good, why not?
No, I can, of course, support Thomas's words about we need to move fast with this data. But I would also supplement to say we shouldn't sit and wait until we have all the data. So also the experience I've had as part of the process in the Nordic countries is that we may have jumped a bit fast into it, and we may rely on generic data, and the industry will criticize for that and will feel that they're not well represented. But we need to get started and building that knowledge also in the industry, and with all these assessors that will have to deal with the calculations in the coming years, so they get some practice before it's real. And an additional comment to the first question that was posted in the chat about the timeline about achieving climate neutrality by 2050, that we may reach that, that's still comfortably far in the future. And we can get through several rounds of standard revisions and directive revisions. But in reality, we don't have that much time since these climate neutrality goals were set. Climate research has told us, oh, wait, but you only have 4 years left of global carbon budgets. So it's ridiculously short time. And I can just recommend that we jump into it, right?
Yeah, jump in.
Though there are still
do not wait anymore.
Wait anymore.
Okay. You're so right. So Cihan, yes, please.
Then I just want to follow up with Thomas's and later Freya's comments. So then I assume in the next recast of EPBD, we won't be seeing a benchmark for LCA of buildings, like embodied carbon emission benchmarks, because for operational energy, you remember there was benchmarks for different regions in the EU. So I think I assume, depending on this lack of data and the conflict of the timeline, the European Commission may not provide benchmarks. What do you think about that? Thomas?
Yes, Thomas.
So, European Commission is aware that across Europe we have different cultures, different climate zones, different policies. And therefore, in a certain way, they try to avoid to come out with benchmark or target values in a certain way now. For sure, there is an underlying universal benchmark, net zero. But now they develop to change strategy. Now they are inviting countries like your home country to develop a national strategy and to report your target values to the European Commission. They are expecting that you will come out with your national mitigation pathway and with your limit and target values, and you should inform, let us say, European Commission about your orders about this. So you can do, and you mentioned already the Royal Institution of Chartered Surveyors approach. You can also say, based on the market in my home country, this is a low carbon building because you start from this, yes. But in future, you will see we have something like distance to target, and the universal benchmark will be net zero. But this means different things in different countries based on different system boundaries. And now you have learned from Freja's presentation, there are so many different sets of system boundaries. So you will have 20 different types of zero based on the system boundary, yes? And this also makes people nervous. And therefore, the easiest way would be to look to this carbon matrix use stage. There are predefined sets of system boundaries like carbon matrix 1, carbon matrix 2, and so on. Freja, I, and others, we are working hard in the Annex 72, and I mentioned this already. There is a background report also available for benchmarks, target values, and so on. And there you can see again a typology of system boundaries. And now you can start such a system, yes, to say this is a zero, but in relation to this type of system boundary. And again, dear colleagues, I mentioned you and I, we are collaborating also in this buildings breakthrough. And also Turkey can put a pressure to buildings breakthrough to say, please come out with clear, very clear terms, definitions, system boundaries, and things like this. Because first of all, we have to improve transparency to avoid greenwashing. And we can collaborate in this field because, we need a little bit more pressure to the organizers of building breakthrough to speed up and to come out with very clear terms and definitions. I always become nervous to listen to zero emission because there are other initiatives also in northern countries. Zero emissions, this means please use electricity on your construction site. So it's emission on the construction site. But we are talking here about energy and process-related greenhouse gas emissions in the life cycle. So in any case, we must use more precise terms and definitions. For sure, climate neutral sounds good, and you can put this to the front page of your newspaper. But for legal requirements, we must be very precise. Thank you.
Okay, thanks a lot, Thomas. Actually, all these are very important issues that we should consider very seriously and your advices. And meanwhile, anyone, Julia, do you want to say a few last words regarding from the perspective of the EPD protocol?
Yeah, you discussed the timeline. EPD, so as I introduced, they will become mandatory, or EN 15804 results will become mandatory for all construction products. And this will also affect the HVAC market, I would say. an EPD project, and that's why I gave you an overview on the workflow in an EPD project. Requires that the company collects data, so the material consumption, the energy consumption, broken down on product level. So it's a little bit different to scope 3. So you really need to collect the data for a certain production line. We have then the LCA practitioner. At the end, we have the verification process, which also takes, let's say, 2 to 3 months, because there is also a limited number of verifiers available. So my recommendation would also be to start with this exercise, to think about the LCA, as it also affects the data from the manufacturer are needed, and very often the processes needs to be in place or needs to be established at the manufacturing side. And then at the end, we also have the verification process. So my recommendation to all manufacturers are that they should start reflecting on an LCA and developing EPDs.
Okay, thanks a lot, Julia, for these last comments. Actually, we are almost finalizing, coming to the end of the time of this panel. Actually, I would like to thank to our panelists. If you do not have any more comments on, as far as I see, there is no also questions anymore. So I really thank. Sorry, yes, please,
if I can make
Freja.
a final
Yes,
comment
please.
to what Julia just said.
Please.
Of course, product-specific data would be excellent to have as soon as possible. And the risk of not making the environmental product declarations for the specific production lines are that these generic values will be used, as we have implemented in several of the Nordic countries, and they will be higher. They will be higher. They will be conservatively put values, so that a building which actually uses products with real environmental product declarations will have a higher chance of obtaining low carbon footprint.
Okay, thanks.
Carbon emissions.
Yeah, this is also an important point, actually. Thanks a lot. And thanks to all of you for these pleasant and informative talks. And actually, I collect a brief message from this panel discussion. There's an urgent and critical necessity to integrate science-based targets, assessment methodologies, and practical solutions into both policy and practice. This will empower a diverse range of stakeholders and key decision makers worldwide to actively promote and facilitate the rapid and large-scale implementation of net zero whole life carbon buildings and HVAC systems design. And also, as far as I see that, the sector or the industry should lead or trigger the processes as soon as possible. For the last words, we are in a new era. Whether sustain a livable environment or destroy it is exactly in our hands. Specifically, it's critical for building sector, which has a significant role in resource consumption. We have no choice without selecting a sustainable, healthy indoor and outdoor environment for the future. Thank you for all of the participants to the panel. I just want to mention a special thank to Professor Lützkendorf. Without his support and effort, this panel would not be structured in this level. Now it's time to close the section. For the last words and closing remarks of the 16th International TTMD Symposium, please keep being online. Bye-bye.